seismic, and weather events. I close the morning report off with what's happening in the local and world news. Thank you, and you can be a part of the morning report by going to twitch.tv/Joe Slick Live. Look forward to seeing you there, and remember, don't get none on you. Well, shoot, howdy. Make sure you like and subscribe, everybody. How about this one? The rabbit hole was created to dive deeper into subjects that needed further examination. Hi, I'm Joe, and my guest and I will take you on a journey of discovery and exploration. We will provide insight and theories regarding the subjects we discuss. Come join us live at joeslicklive.locals.com, or you can join us on Facebook or Twitch or YouTube. Thanks, and look forward to seeing you. And remember, don't get none on you. Don't get none on ya. Anyway, eat your Kit Kats, everybody. I'm just teasing. I'm not supported, and I don't get anything from telling you to eat Kit Kats because I don't give a hoot. I know my buddy likes them, so I'm partial. I'm enjoying an M&Ms. I don't know. I'm a little bit zingered. Just popped a beer open, and my other brother's not here yet. So, yeah, I hope everything works out. We'll eat Kit Kats. Kitty cat, we're not eating you. I'm not going to eat no kitty cat. Oh my gosh.
Well, if there's a shortage of chocolate, nobody will be eating Kit Kats. That'd be way less.
Right. There's some sort of issue that I saw in the news saying don't eat the micro chocolates. Did you see that?
No, I never saw that. Just there's going to be a shortage of chocolates, but they still have them at the store. So
yeah, they get more expensive though, don't they? Yeah. I think it's a way to increase the price. Oh, there's a shortage. Right. How did you make it last week? Well, yeah, Tom, Dick, and Jane made them. Is Tom, Dick, and Jane still working? Yeah. Are you still getting the materials? Yeah. There's no shortage. You're just upping the price. You ball squeezer, you. Oh, yeah. Put some spicy V8 in my beer. It's kind of like a Bloody Mary for some people, but I don't want the hard alcohol. Anyway, nothing happening there on deck. You can see the volcanoes going still. And what's the latest, Canuck? I know you know the latest.
Well, the latest is they're waiting for the lava thing to break again, the lava pool, and come out and run down over the highway again. That's what they're waiting for right now. Because they said the lava pool.
How tall is the highway now?
Well, it's still the same one as over it. But they're worried another one is going to come down. So, well, yesterday they were trying to figure out what they were going to do to make the walls higher or whatever, but I don't know if they've decided anything yet or not, because there was bad weather again there today. It was like super foggy, and the gas was blowing up towards Reykjavik, so it wasn't good.
I saw that.
So, but they did fix the southern road, so you can actually, they put dirt over the lava flow, so now you can actually drive in to Blue Lagoon from the backside. now, so you can
Yeah,
actually get.
Kat. I want to make sure that we're not, because we are live everywhere. I want to make sure that I'm not being against copyright. So I will look at it here. I can do it this way. I saw that you posted it. That's the quickest way to get in any kind of trouble. All right. Yeah, we can watch this. All right. So share screen, light shot. All right. Share. I'm going to share this with you.
Well, and they had one of the restaurants open there, and
there you go.
Town for tourists to go to too. So now that the road's back open.
Oh yeah. Yeah, they still want people to go over there to the Blue Lagoon. Are you freaking kidding me? Who wants to go to the Blue Lagoon?
Well, there's people there today, I guess, because they can drive in from the
south
side.
Mm-hmm.
Yeah.
I mean, is that the only thing they do? I mean, make babies, watch TV, and go to the Blue Lagoon. There's 3 things to do on that stinking island. And the weather's crap. So I don't know. Anyway, Kat, I'll send you a link. You can log in and you can tell us about what you're seeing here. If you want to come in for a brief moment.
Yeah, because I saw pictures of the golf course before from all the damage from the earthquakes, but they must have fixed that if the people are using it.
You're shy tonight. You were on one time before and you weren't so shy. I think everybody liked it and you got kind of different about it. I don't know how to call it. You were fun to be online. Yeah. But
they're losing like so much money there for stuff. I'm not surprised that they're trying
in the ICELAND.
Yeah.
Okay, it looks like we had a 3.8 just off the Atlantic Ocean. Somewhere out there in the middle. I don't think USGS has anything close. Yeah, let me see here.
Well, there's a 2.8 in Iceland right by Bardabunga.
Bardabunga! I don't know why, but I love that. So anyway, so she sent us this link, and I don't know why, but I guess because there was a quake out here. And I guess I can open up Canada, and Canada will tell us something. 4.9 McPherson, south of Fort McPherson, and then Keno YT. So, what? Come on, it's running slow. Canada, come on.
Yeah, it's froze up.
Boy, it's not doing it. And it give me a map. Recent quakes. All right. No, that's archived. It should give me a stinking map. Why isn't it doing it? Here we go. Well, why? I think it's broken.
Yeah, you're stuck in the part where it gets you around in a circle.
Yeah,
because it's the page where it shows the recent quakes, and then you can't go back to the map thing.
Yeah, where the stinking map at, man? Well, shoot, howdy.
Because it's a 30-day one.
Yeah, the 30-day one. Yeah.
30-day map.
Put it in English. It's in Francois.
Just search 30-day map.
I saw it. I clicked on it. Nothing happened.
It didn't do it.
No.
Unless they've got it messed up or doing something.
Well,
you're doing it over.
Yeah. Well, they didn't want my buddy. out there in Canada. So 30 days. Here's region. Can it click for a region? I don't want a region. Just put list of pots on a map. Click region. Hey, kids, see that? Shoot, howdy. I don't know what's wrong with it. Normally it comes in.
Quake Cat put the link in Twitch, so see if it works on that.
Nope. Her. I know, sweetie. I did it. I clicked it. It ain't coming out, man. Report a problem on this page. Yes.
Yep. We've eliminated all the quakes.
No, I'll return my visit. I'm ready to start my survey. Yeah.
Probably because everybody's all upset about the new report on Cascadia.
I don't know. What the frack?
Yeah, so now everybody in Vancouver's all paranoid. That's what I read. That's what I read the other day.
Yeah. Yeah, because there's something going on, but you said there's a report, the tremor report in the log?
No, it's not from that. It's the new Cascadia study that came out the other day on June 7th. Yeah. Because the nines actually started up by Vancouver Island. That's how they go.
Canada being polite and not bothering with maps.
Yeah.
Well, shoot, howdy.
Well, here, I can post the new study. Some of us have already looked at it.
I didn't have a chance. I've been working my balls off. So I apologize. I pretty much just facilitate you to come in and give us what your opinion is what's going on, and try to engage you and engage others. But
because they figured out it has like 4, possibly 5 segments, same as Nankai.
I agree with them. I agree with that. I've been saying that forever. Yeah. Yeah.
Oh, I got to reload the page here.
Reload the page, buddy, and we'll read it to the people. Power to the people. We'll read it to you. Seeing how Canada just went. Yeah. Uncle Milty, when are we going to get you on here, buddy? I know Quake Cat, she'd been on, but she got a little scared. Who's doing this one?
So there I posted the
all right, brother.
Article.
Oh, the physics.org. All right. Cascadia subduction zone, one of Earth's top hazards, comes into sharper focus. Right. Outer wedge, transition zone, inner wedge. Outer arc high, shelf, forearc basin, older accretionary rocks. Yeah. Deformation. The rupture path. Where's the water? Off the coast of southern British Columbia, Washington, Oregon, and Northern California lies a 600-mile-long strip where the Pacific Ocean floor is slowly diving eastward under North America. This area, called Cascadia Subduction Zone, hosts a megathrust fault, a place where tectonic plates move against each other in a highly dangerous way. The plates can periodically lock up and build stress over wide areas, eventually being released when they fully lurch against each other. The results? The world's greatest earthquake, shaking both seabed and land, generating tsunamis 100 feet high or more, such as a fault off Japan 2011 Fukushima nuclear disaster. Yeah, remember that? Mm-hmm. Similar zones exist off Alaska, Chile, New Zealand. among other places. There's the Chile one. Yeah. At Cascadia, big quakes are believed to roughly happen every 500 years, give or take a couple hundred years. The last occurred in 1700. Yeah, how many years is that? It's 324. Yeah, scientists have long been working out to understand the Cascadia subduction zone, subterranean structure, and mechanics in order to delineate places most susceptible to quakes, how big they might be, and where their warning signs are. There's no such thing as a predicting an earthquake. Rather, scientists try to forecast probabilities of multiple scenarios, hoping to help authorities design building codes and warning systems to minimize the damage when this shit happens. A new study promises to greatly advance this effort. A research vessel towing an array of the latest geophysical instruments along almost the entire zone has produced the first comprehensive survey of the many complex structures beneath the seafloor. They include geometry of the downgoing ocean plate and overlying sediments and a makeup of overriding North American plate. The study was published in the Journal of Science Advances. Ding! Right here. I'm not going to read the abstract, but yeah, they're checking it out. So here's the actual report. So I'm gonna put that in there for y'all. I'm not going to read it. I just wanted to read what.
The report itself is super long because I read it, but it took me forever.
It's complicated, buddy. The model is currently used in public agencies were based on a limited set of old, low-quality 1980s era data, said Susan Carbot, a marine geophysicist, at Columbia University at Lamont Doherty Earth Observatory. You know, just at school, okay? All these words. Well, it's going to be... I hate that. That's why it takes you so long to read something. It's like, yeah, the guy's name or the girl's name, Susan Carbot, one of Columbia University, bang, who led the research of the megathrust has much more complex geometry than previously assumed. The study provides a new framework of earthquake and tsunami hazard assessments. The data was gathered during a 41-day cruise. Oh, how nice. In 2021, a shitload's happened since then. By Lamont's research vessel, the Marcus G. Lanseth.
Yeah, it took them 3 years to do all the data.
Yeah, to bring the data together. Yeah. Researchers aboard the ship penetrated the seafloor with powerful sound pulses and read the echoes, which were converted into images somewhat similar to how physicians create interior scans of the human body. Yeah. Yeah, synopsis. Earthquakes could happen at any time, right? One key findings of megathrust fault zone is not just one continuous structure, but is divided into at least 4 segments. I've been saying that for 4 years. It's segmented. I'm so happy somebody backed me up. And I'm just a knucklehead. Oh, megathrust fault zone, but is divided in at least 4 segments, each potentially somewhat insulated against movements of the others. Scientists have long debated whether past events, including the 1700 quake, rupture the entire zone or just part of it. A key question because the longer the rupture, the bigger the quake. The data shows the segments are divided in, by buried features, including big faults, where opposing sides slide against each other perpendicular to the shore. This might help buffer against the movement of one segment translating to the next. We can't say for definite that means that one single segment will rupture or that definitely the whole thing goes at once, said Harold, a geophysicist and a co-author of the study. But this does upgrade evidence that there are segmented ruptures. See, my mind was that it would rupture, and then the next one would go, and then the next one would go. And I'm not talking like, weeks or years apart, relatively close in proximity in time, much like the Chilean megaquake that happened, in 60? Oh, no. I don't know what year that one happened. When did that one happen, Canuck?
1960.
Yeah, 1960. See? And then, yeah. The imagery also suggests that their segmentation, the rigid edge of the overriding North American continent plate, is composed of many different kinds of rocks, formed at different times in many tens of millions of years, with some being denser than others. The variety of continental rocks causes the incoming, more pliable oceanic plate to bend and to twist to accommodate the difference in the overlying pressure. In some places, segments go down at relatively steep angles. In other places, shallow. The researchers zeroed in on one of the segments, in particular, which runs from southern Vancouver Island alongside the western Washington state, more or less ending at the Oregon border. The subterranean topography of the segment is relatively rough, with ancient stuff, like he said, with oceanic features such as faults and subducted seamounts rubbing up against the upper plate. Features that might erode the upper plate and limit how far any quake may propagate within the segment, thus limiting the quake size. In contrast, Vancouver, Washington segment is quite smooth. This means that it's more likely to rupture along the entire length at once, making it potentially the most dangerous segment. Now, they just said the researchers zeroed on a segment particularly which runs southern Vancouver Island alongside Washington state, more or less ending at Washington or Oregon border. The subterranean topography of other segments are relatively rough. Other segments, which stops the propagation all the way down. This means,
so 8's at the bottom, 9 at the top.
Yeah. Or 7s, 8s, and then 9. Yeah. Also going north anyway from California. Also, the segment of the seafloor is subducting under the continental crust at a shallow angle relative to the other segments. In the other segments, most of the earthquake-prone interface between the plates lies offshore. But here the study found that the shallow subduction angle means it probably extends directly under Washington Olympic Peninsula. This might magnify any shaking on land. It requires a lot more study, but the places like Tacoma and Seattle could mean the difference between alarming and catastrophic, said Tobin. A consortium of state and federal agencies, academic institutions, has already been poring over the data since it became a sort through the implications. As for tsunami hazard, it's still work in progress. Keyline Wang, a research scientist of Canada, USGS, and they get the CAVS US, right? Canada's bullshit. Because they only do it once a month. Who is not involved in the study. Wang is using the data model for features on the seafloor off Vancouver Island. It might generate tsunamis. In general, a tsunami occurs when a deep seafloor moves up or down during a quake, sending a wave to the surface that concentrates its energy and gathers height as it reaches shallower and coastal waters. Yeah. Wang said... I'm not going to let that joke go. Results will go to another that model tsunamis themselves and after the other group that analyzes the hazards on land. Practical assessments could affect building codes. All right. Yeah, that's a good article. Thank you, Canuck.
Yeah. So and it goes into like super detail with charts and stuff, and it names like how the segments are divided by the faults that are coming in offshore, but they only go in 50 kilometers. So they explain what the ones offshore, how they're connected to the ones on land. Like they go into super detail, like how the segments are divided, and they have chart there because they figured out how fast each segment is subducting, and they're all like doing at a slightly different rate from the other one.
Oh, that's pretty interesting.
Yeah, which is why they say when it slips, the bigger one, that's why it makes nines, because it
And it's
slips
not, and you know what's
more.
funny too? They can't see this, but got it. Let me see. How do I let you see? How do I let you see it? Okay, go back to here, and then share screen. Well, shit. Howdy, window. There we go. Untitled. Here we share this one. Loading. Okay, share it. All right. So on here, in the north, it goes down like this beneath, and this is the rollback right here, and this is where the area of large quakes happens and tsunamis. Most of the earthquakes are happening down here, though.
Yeah, because there's a whole bunch there's a whole bunch at the bottom that can happen, but they don't necessarily generate
the ones at in California and up in Oregon, it's more dramatic drop off the plate boundary, and yes, it's still overriding, but it's not like what's happening in Vancouver and Washington. So what do we know about Vancouver and Washington? Well, we had Silesia, right? I don't know, Silesia, right? I misspelled it. Sorry. I think it might be an I right here. Silesia came across 55 million years ago. What's the other one? It's up in Canada. It's up in Canada now.
Yeah, Rangelia.
Yeah, okay. That happened 110 million years ago. All right. So these two different events have something that happened 88 million years ago, which we all studied through Professor Nick. But even Silesia coming aboard, the 88 was the wild Eocene years, right? It happened between 55 and 88. Interesting that Rangelia hit Vancouver, Washington area 110 million years ago. And this is the same time period that between 110 and 130, I'm stretching it just a hair. That's when the Sierra Nevadas in California, that's when they were volcanic. So putting it in, you have to put it in a kind of context. Rangelia came aboard somewhere, smashing on North America 110 million years ago. That's the same time that Sierra Nevadas were created. The San Andreas was not around. Okay. So this is pre-San Andreas. San Andreas is around when Silesia came around, about 55 million years ago, if I understand it correctly. That's the same time, roughly, the Grand Canyon was created as well, between 5 million and 55 million. Also, I think when Rangelia came across, there was the Wasatch Mountains were created at about 110 to 130 million years ago. So, and this is in Utah. I'm pretty sure about these numbers. It could go all the way to 160. I'll leave Quake Cat for her opinion on that. So we have the Sierra Nevadas at this time period, Rangelia smacking up against Vancouver, and the Olympic Peninsula wasn't there. And this is all Washington and then Oregon and then Cali, right? Or Cali's all here. All of this stuff moved north at 110 to 130 million years ago. And every 40 million years ago, or every 40 million years, the land moves 400 miles, right? So if you go 400 multiplied that by 4, that's 1600 million years, right? And that's where we got Rangelia being way down here, somewhere roughly northern Cal and Oregon and into Washington. Then it broke up when it smashed into Washington. And then part of it stayed and half of it left. That's what we're being taught through the courses that we've all taken. Now, we've taken really advanced courses by, it's kind of like, you go to college and you just kind of sit in a class, but you don't get a grade. We've had that opportunity. We've had a 100 course. We've had a 300 course and a 400 course. And then we've had exposed to high level discussions among researchers and geological staff at the colleges that are 400 and 500 level courses. And yes, we're not talking that we're studying the rocks and stuff like that. No, we're getting a cursory overview, wet your whistle, so to speak. And that's what Professor Nick does. He's a recruiter. That's what he does for Washington. So him doing that it's been a great service to us all. And we've learned so much. That whole segments are found on so many levels. Ranges from 38 to 24 million years ago. Wasatch, okay. So Wasatch comes around Wawa. And Wawa was way bigger than, I think Wawa was 33 million years ago, right? Way bigger than Yellowstone ever was. And it exploded and blew itself out. That is if the dating is right. So we all have to kind of watch the dating thing, watch the dating game. But I think it's interesting that you said, Canuck, by reading that report, that the southern part is more like it's two plates sliding side by side and not necessarily overrunning it. You know what I mean? Like where the San Andreas is, it's sliding side by side. And that goes all the way up to or near Washington and Vancouver. I wonder if it's not pulling out from underneath it versus pulling into it. They always say it's going underneath, but what if it's being like if somehow there was a big push and the whole thing went on top and slowly it's coming out from under it. And although there is pressure to force it in because the way the eddy works, because of how the Pacific Ocean is all moving at I don't know, a 2 to 3, 2/3 faster than North America is.
Well, the Juan de Fuca Ridge, because it's a spreading ridge, is pushing it all.
Sure.
In under, and North America is coming down over it, right?
Right. And there's plenty of strike slips on that Juan de Fuca.
Yeah, because it says in the study they used, because they did the same thing in 2012 on the Juan de Fuca Ridge. So they went over and got all the data from that. Mm-hmm. So that's how they figured out how fast it's actually, each segment is slipping underneath. because they had to combine the data they had from 2012, which was the same as when they did all the stuff with Axial out there, Seamount and all that. It was all
Right,
around.
right,
It
right.
was all around the same time they did all this. So they put that data that they had from 2012 and then this new data that they got from 2021.
Uh-huh.
And once they map both things, they could figure out how fast each segment was moving. Because there's they have a diagram in there that has like all the slippage rates for each segment on there.
That's what I'm currently looking at for right now. Yeah, but
And
go ahead.
it's like slightly different depending on which segment it is. It's in there somewhere, but they have so many friggin' maps.
They have a lot
I
of
read the whole thing. It took me like, I don't know how long, 3 hours or something for me to read the whole thing. So it's like crazy. And they have it like all broken down, like what the dividing lines are between each segment. And they have all the names of like the canyons and the faults and what they connect to on land.
right.
And it talks about in there how all these dividing faults that are east-west ones off the coast, they actually connect on the land, but they only went in so many kilometers. So they were surmising what fault lines they knew about that it was connecting to. But they said, like at the end, when they said all the stuff that still has to be done as a result of this, that they have to find out like where those faults, what they're connecting to inland, because when that segment goes all along those canyons or faults that are all connected, it could enhance the shaking way inland. So it would change what their estimation is for a 9, right? Like how far inland it's gonna, which I understand because I've read about all those inland faults that are east-west reverse faults, and all the new studies say that they are going to cause more shaking, and that Vancouver and Seattle are both in worse. They're going to get worse shaking than what they thought. And now, because of this study, they got to go redo it all again because it's talking about all the faults that connect from, like when it moves, the stress or the shaking is going to follow these east-west faults inland. And I read like Goldfinger's response to this because, of course, he read about it. That's basically what he said, because he said they're going to have to redo all the shake maps and all the stuff all over again because they're supposed to do them all over again in super detail by 2029 as their next.
Oh yeah. So where was Goldfinger's response? How did you find that?
I looked it up. It was because I looked at the responses to this new study by state, and he's in Oregon. So when I looked up the Oregon response, he was in the article. And then I just did the Canada one the other day because that was all the people at UBC and Victoria and Vancouver. And they were saying the same thing. They were saying, well, now we got to redo our, because they just did the Vancouver shake thing for Cascadia 2 years ago. Because I read the study and they said that it would, based upon their calculations then, Vancouver would shake even more because of what it's built on, even more than Seattle because of the basin that it's in and like what the basin is made out of. But now, because this new study that just came out, they're going to have to go and they said redo it all again because they have to factor in all these faults that they weren't thinking about before that connect from offshore and come in. So it's crazy stuff. And that's basically what Goldfinger said too. So he said now they got to redo. Because like in the actual study, they were talking about all the turbidite information that they got from Goldfinger, which he used to find out the 10,000 year record of the Cascadia quakes.
Well, let me ask you a question. The turbidites. Turbidites are little animals. They're shells that populated the seafloor. Am I correct?
Well, there's stuff that's in the core samples that they take.
Yeah. I got you.
They took off the coast.
Right. What would happen? What would happen if there was a tsunami or a large earthquake that uplifted a large part of the land, and it would dislodge that stuff and place it somewhere else, like a 9 or something earthquake, or a 10 or a 12 for that matter, that would kind of throw off everything, wouldn't it? If there was a large body.
But it's the stuff that comes down, like say
the runoff from the on shore. Yeah, I got you. Runs off into the.
Well, it comes down, like say the example they gave when I was trying to understand what it was like they'd say where they got the turbidite from. So if it was like Astoria Canyon, where Astoria,
right,
where the Columbia River comes out.
Yes, sir.
Well, they did the core sample down in that canyon. So
anytime the fan's got to be freaking huge.
Yeah, so anytime there was like a big quake, all that stuff rolls down into the canyon. Well, they did this like all over, right? At all sorts of different places. They took samples and then they went to match them all up because they could see where there was like a different layer of stuff. And then they went and tried to match them all up from like all the different samples that they took all the way, basically the whole Cascadia subduction zone. They took samples of it and then they see where they matched up or where they were different. And then they could pick going back through time and, well, estimate based upon how long ago it was that the big quake happened from the one. And they're doing it like this turbidite thing all over now, right? It's like everywhere. So they were just like one of the first ones to do it in off Cascadia, but now they're doing it everywhere. So that's how they're trying to get all these 10,000 year record or 4,000 year record, or depending on how far they're trying to go back. That's what they're doing with all these tsunami deposit things and stuff. That's how they're trying to figure it out. But they can do it on land too, like in lakes. It's the same thing. Take a core sample in there, which now they're trying to do that to figure out when, well, if it was the same big quake was felt way inland or not, or if it was like a separate quake altogether. Because sometimes you get 7s inland, right?
Well,
so that's what they're trying to figure out.
At least in SoCal they do.
Yeah.
And notice I didn't say we do.
Which the last I heard about where Goldfinger was, he was down off Long Beach and Huntington Beach, and all that. That was last year because
somebody's going to have to do the San Joaquin Valley, do core samples throughout the San Joaquin Valley. Now I know they did it in. Good night, Uncle Milty. Big hugs to you, buddy. And 4.2 off the Gulf of Cali. Yeah. The San Joaquin, I know they've studied it for and they've said that it has sank at least 8 times. So Muzzy's talking about it. Yeah, 4.2 off of just south of Hermosillo. Los Mochis north of that. So right in that area where it's always, Wamas.
Yeah, the
Obregon. Yeah.
The 5.7 northeast Pacific rise was yesterday.
Oh, pretty good little booger. Yeah. Cali's going to feel that one soon. Yeah. In fact, I'm looking at Cali now. Nothing. It's just slow. 4 Mile Road.
So we'll see if it does the swarmage thing again.
Right.
Mexicali and then Raleigh.
Well, yeah, Texas has picked it up. That's what Muzzy was saying. That Texas picked up that earthquake that just happened. So, hi, Moni. Yeah. I'm doing research as Canuck and I are talking because everything's kind of in flux always. And, things are happening. Significant quakes, one in Southern California, Indio, which is right. Well, Indio. it's not by that's on the San Andreas. Yeah. Or just, east of it by 10 miles or so. So it's not where Big T-shirt Billy is. He's on the San Jacinto fault. So it's on the backside of the same mountains. There's a mountain range between him and the San Andreas. He's on the one side. San Andreas is on the other. And this quake here, a 3.4 hit today there. And up in Tom's Place at 2.7. Tom's Place is up by Mammoth. And that's starting to pick up, it seems. East of the 395 and east of the Owens River and east of Lake Crowley. And then, of course, up there, Cobb, it's got a 2.6. That's all that's happening in Cali that's major, meaning major is like really minor, 2.6 really. So it's not saying that, but there is a bit of a swarm along the San Jacinto Fault south of Scooby and Indio, where the 10 freeway hits Indio, and the it's very shallow there. It's like almost sea level, Indio and Mecca. So there's the mountain ranges, the San Bernardino mountain ranges that go up toward Yucca Valley. And we just now have a 1.2 up in Running Springs, which is the epicenter of the 1812 quake, Running Springs, Lake Arrowhead. It's not there, but it's closer to Redlands. So, but it is the San Andreas is moving ever so slightly. But Ridgecrest has bounced a little bit today, and yeah, there is movement along the Wasatch all the way down into Vegas, and from Vegas all the way up to Tahoe, from Tahoe all the way over to the Gorda Escarpment, and then along the San Andreas all the way down. And the San Jacinto was very busy south of San Jacinto Mountains to Borrego Springs and the Salt Sea. And that would be the Borrego Springs there. So that's what's happening in Cali. And there's a bunch of little quakes all over Seattle. There's Edmonds, Washington, West Ellis, the rim of Washington. Wenatchee had a little, just north of it, had a small one. Desert Air had a small one. Yakima had a little small one. And then Mount St. Helens. Yeah, there's plenty of little bangers here. If there is a swarm, it's 1, 2, 3, 4, 5, 6, 7. If you count the one off of it, 8. And so that's what the USGS is reporting. So Mount Rainier, nothing. But between Mount Rainier and Mount Adams, there's one little quake, or 1.4, Packwood, Washington. But all of that stuff's going on, and we're here to talk about it in a sort of way. I don't know why we.
Yeah, and I was reading other interesting stuff there today that people were talking about all the sonic booms they've heard between northern Los Angeles all the way out to Lompoc. This has been going on.
Be north of LA. Yeah.
Yeah. The last few days, but the military base, the Space Force base out there, said they were launching rockets. But
yes, sir. What happened? I don't know exactly where it was, but there is a F-18 Hornet. It was testing a long range missile that would go about 130 miles, an air to ground or an air to air or an air to ship missile. And normally they don't use that missile, but they can. So I think part of that's happening out there, and because they're preparing for, the inevitable. It seems long range stuff, you know. Also, they're testing dummy nuclear bombs off of F-15s. That and they're doing pretty damn well on those too.
So there's all sorts of interesting stuff going on.
Right. But yeah, I mean, shoot. So this report or this study you did, what exactly did Goldfinger really? I mean, because I'm interested in the Goldfinger dude. What was his kind of, other than saying, hey, they're going to have to revisit everything? Was he kind of did he keep things close to his chest? What his opinion was, or?
No, well, he thought the study was good because it had way more detail on stuff, right? But he said basically because of that, like he said, it was like going to be the basis for the future study of Cascadia to figure out how it actually
Works.
That's basically what he said.
Did he?
Because they got to add way more stuff. And
Did he? Did he kind of bring anything up to his latest study?
no, he never said anything about what he was. Because I've been looking for that lately,
I know you have, yeah.
and I haven't seen anything.
He's with Oregon State, Chris Goldfinger.
Yeah, Oregon State University.
Yeah.
But that was the last I heard when I looked where he was and who he was working with down there, because it's all the Southern California fault people. Because their names were on all these different studies that I read, and like in those fault studies, it's said that Goldfinger's here to do this, to find out the 10,000 year record of the Southern San Andreas going off. Like when I was reading about the other faults, because all their names are all listed on all these different fault studies. Because I've read so many of them, I know who like the experts are on each fault.
Right.
And so I see their names, like when there's one particular fault study that comes out, it'll have the person's names and it'll list who else is like working with them or trying to figure out stuff. So that's how. And another thing I do, I follow their graduate students or their master students, because they send their master students.
Yeah, there you go. Now you got smart, buddy.
They send them to do different stuff, so then I see where they send them to.
Yep, that's how it works, because it's always the young ones, and then the guy that's got the big medal on his chest, he's the one's going to take all the glory.
So I don't know how long it'll take them. Maybe it'll take 3 years before he has all the data.
He hasn't done anything. He hasn't done anything really lately. Oregon State. He's with Oregon State since 1990 to present. 87 he was there. 74 Humboldt State University. 74 to 79. So he's a marine geologist, and 2013 he wrote Statistical Analysis of Great Earthquake Reoccurrence Along the Cascadia Subduction Zone, October 2013. So he's on board with that one. And then super earthquakes and super cycles 2013,
because he did both the record 10,000 year record of Cascadia and the 10,000 year record of the Northern San Andreas.
Right. There's another article that his name's on, talking about the 9.0 in Tohoku, Japan, as well as the 2004 Sumatra mega 9.15 quake. Have humbled many earthquake researchers. So neither region was thought capable of making those kinds of quakes, but they have.
Yeah, because he was in Japan there talking to the other people at a conference when the 2011 happened. Yeah. So he was actually in Japan.
January 24, the seismic potential of Lesser Antilles subduction zone is poorly known and highly debated. Only 2 damaging earthquakes have been reported in historical record, 1839 and 1843, but the sources of magnitude are still uncertain. Global navigation satellite systems and coral data contradict each other, and no conclusion has been researched. Sedimentary records in the Lesser Antilles 4 arc basins provide evidence of large lake quaternary megathrust earthquakes. I don't even know where the hell that is. Where's the Lesser Antilles? Is that out there in the middle of the Atlantic?
Yeah.
All right.
Yep. Well, it's down Caribbean, I think, Lesser Antilles.
I don't know. North American plate. Yeah, it is. And it's talking about the megathrust that happened 1843 and 1839, 1906. We talked about that one. Yeah. There you go. So
because basically how it works from that is you get a big
off Antigua, Barbuda, and Guadalupe.
Yeah, so to get a big quake on the west coast of North America, you got to have all the other parts of it moving big time too.
Right.
That's basically how it works. So I've started to do a preliminary research on the San Jacinto quakes, the historical ones.
Right.
And I noticed from the ones I've done so far, I had to go back. I had a list of them that I wrote down before, but the first 3 that I did, there was always big stuff in South America going on, so like 7 pluses. And another thing that's interesting, Alaska, Kamchatka through to Japan, we're always having 7s or 8s. So when San Jacinto goes with like a high 6, that's what's happening, which is kind of like the monkey in the middle. But it still needs to have like South America going with big quakes and like Alaska through Kamchatka, Kurils in Japan. So I thought that was pretty well. I looked up the first 3, 1899, 1918, and 1923. So those are the 1899 and 1918 were the 2 biggest ones that did the most damage on the San Jacinto. And they've done studies where they figured out all the segments of San Jacinto, which I never went into that in super detail. But the reason why they talk about the Anza Gap is because they figured out that segment hasn't gone big for like a long time. I forget what it said. But they have the San Jacinto all divided up into segments too, and they know from the fault studies like how long ago each segment had a big quake. And there's studies on San Jacinto that it was responding to what happened in 1857, because the big quakes that have happened since then have all come down like at an equal step, even though they've skipped over some segments. But so there's all sorts of crazy stuff about it. But so now they're trying to figure out like that's why they talk about Anza so much, because it hasn't gone in a really long time. I forget how long it is. 4,000 years or something like that, by what they figured for that segment. So there's a lot of crazy stuff going on with San Jacinto, but they've also figured out that it's actually, I forget what they said for the number, 20% out of the quakes they found on the San Jacinto happened at the same time as the San Andreas went off. So San Jacinto goes with San Andreas sometimes too, which the last time it did that was 1812, which they figured that out. But now they've gone back and figured out by doing the same things, the fault studies on each one, and some of them match up. So that's how they figured out that it's gone off 20% together out of all the ones they know about on the San Andreas and the ones they know about on the San Jacinto.
Right. 20% of the times, both of them go together.
Yeah. So that was the
That's
latest
pretty
numbers.
significant. That's
Yeah.
significant. Yeah.
So that's the latest numbers as of, I don't know what the study was I read, 2022 or something, I think it was. So they know that much anyway. And they had the numbers, but I don't remember what they were. They said there was like, I forget, like 19 on one and 21 on the other, but whatever they figured out to be, whatever that 20% number that were the same, they went off together. And 1812 was the last time. So it's crazy stuff, but this is what they're doing with like everything. So that's just I try to figure out where it's coming from, right? So that's what I do. So I start with one and then I see if it's the same pattern over and over and over again. And see, 1899 was the Yakutat quake. So you had those big quakes up there. So
Yeah.
when I looked at the other ones, I said, "Oh, well, that's interesting. Now I'm going to look at the other years and see what it was doing." And I found it was like similar.
So there, in essence, you're saying that there is a correlation between large quakes along the west coast of the United States or North America. They don't have to be like 1 minute, the next minute. They can be a year, even 2 years apart, or even 3 years apart.
Yeah, I do a year.
So
that's how I started doing it. I take whatever the quake date is and I work backwards.
Right.
But as I've gone into it more, like then I start looking at nines. Well, it's easier to do it with nines. And then I do it with eights.
There hasn't been so many nines, bud. I mean, Andaman
but then I
Sea,
can
Chile,
see,
Alaska.
I can see that it's doing the same patterns. It's
Sure.
just over a longer period of time.
Right. Yeah. So
like
a pattern of eights
so,
will go sooner than a pattern of nines. A pattern of sevens will go sooner than a pattern of eights.
Yeah.
So that's kind of what. So there's almost, for lack of better words, a buildup of sixes to make a seven, a sevens to make an eight, eights to make a nine. Yeah. And I wonder over the last 100 years how many eights we've had and how many nines we've had, and if that number holds over the last 200 years or 3 and 4 and 500 years.
Yeah, like the big ones just don't appear out of nowhere. There's always a build up to them.
Yes, sir.
So before you get a 9, you're going to get a whole bunch of 7s.
And the location doesn't necessarily have to be pinpointed. You can, have like up in the Andaman Sea versus where they think it's going to be next, which is about 600 miles south, maybe 500 miles south, right there off of Sumatra, northern Sumatra, where not further south than Banda Aceh there. Banda Aceh is on the point. So the last story I've heard is that it's predicted that the Nicobar Islands area will be the next, mega quake, a tsunami, so to speak. But the mega quake they had there in Andaman Sea was out to sea, a couple 100 miles. It's, and maybe we shouldn't focus so much on exactly trying to pinpoint rather than look at the fault itself and say along this fault or along this subduction zone, there's a potential or potentiality for a megathrust quake like the Andaman or the, Cascadia or Alaskan or Chilean. Those are the main ones. Mexico has them as well. Central America has them. Megathrust quakes. We just haven't seen it. There he is. There's my buddy. If I remember right, I think there has been 4 9s in the greater quakes in the last 100 years. I might be wrong. Yeah, since 1960s, the last 50 years or 60 years, there's been at least 4. So I don't know what happened prior to 1960. I think there's a 1940s or 1950s. Japan had one. I didn't even say Japan. Shit, Japan's another mega thrust quake. It had a 9 here. Well,
Yeah, well, there's been like Kamchatka ones too that everybody forgets about.
And that's where the Pacific Ocean's going, Pacific Plate anyway, right into Kamchatka. So you got to wonder.
Because the big Kamchatka ones were 1952, 59.
Yeah. So
the same years of Hebgen and Tehachapi quake.
Tehachapi. The Hebgen was what, a 6 something?
No, it was a 7. 7 plus
7.
Yellowstone. That was in 59.
I mean, it wasn't in Yellowstone. It's outside of Yellowstone. I don't see it as being related, but maybe some people do. I don't know.
Because the 59 one was like almost a 9 in Kamchatka.
Yeah, Flagstaff, Arizona had a 7 as well. I don't remember the year. I can look that up real quick. Flagstaff, AZ.
And I'm getting I remember all the numbers now. So when I go to study one, I remember.
Yeah, that's why we love you.
I remember all the big quakes that happened that year, and I'll say, "Oh, well, that's interesting."
All right. So May 3rd, 1887, Arizona Southwest experienced a major earthquake, an estimated 7.2 on a Richter scale. The epicenter was Sonora, Mexico, approximately 40 miles south of Douglas, Arizona. That was 1887. That's when we started our rabbit holes for.
Yeah, and I found all sorts of other stuff about that too, because the Ligurian Sea quake was that year, 1887, which is southern France. It's on the same liniment line, coming right down, going right down through Sonora, coming the other way through Charleston, because Charleston was in 1886. So that was the year before. So all this stuff that I've traced backwards, I find the historical quakes, and then I go, look, it's the same year. Oh, look, it's across from here. Look, it's doing the same thing as what it did before. It's doing it again. So it's crazy stuff.
Yeah. Sorry,
and 1886 had a lot of crazy solar stuff. I never looked up 87. 1887, but I imagine it was the same thing. Because I know Grimsvötn was going super crazy from 1882 to 1889, erupting in Iceland.
So the AI says the largest earthquake that occurred in Flagstaff, Arizona, is estimated to be around a magnitude 6.9 to 7. The entire Lake Mary Fault were to move. The Lake Mary Fault is steep, almost vertical fault that runs for about 40 kilometers south of Mormon Lake into southern Flagstaff. It is part of the Northern Arizona seismic belt, which is the highest concentration of active faults in the state and is most seismically active region. So, and it's volcanic. I mean, Northern Arizona, where there's everywhere around me, there's old volcanics. So, I'll be doing a lot of field work once I get established here, and the weather's not so freaking hot.
Well, you're actually closer to the hurricane fault, so it's worse.
Yeah, it's north of me, 100 miles or so, and maybe even more. It's in the hurricane fault dead ends up there in St. George, and which it goes kind of curls from east to west. And so it points more toward Vegas than it does me. And I think it's the hurricane fault that will close the Grand Canyon, and Colorado River will flood. And I just hope it doesn't flood me, because I've been to it recently, and it's a fast moving thing, man. Yeah. There's amazing how fast that Colorado River moves right there into Lake Mead. Lake Mead is draining, and because of the lack of snowfall in the Rockies. It's at very low levels, but it is an incredibly large, massively large inland sea. So it's like, wow. But they call it a lake. But it's mind-boggling how big it is. It's not like the Great Lakes up there where Cat lives, but in the middle of the freaking desert. And it's why they made parts of it. Well, I don't understand why, but hey, whatever. Maybe it's the rock kind that needs, the rock type or something. I don't know. But anyway, it's pretty crazy.
And I have the newest study on Campy Filagri too. So everybody needs.
Okay, go ahead. Give us that while we close up. So after that, we'll close up. Go ahead.
Because it's super detailed. It talks about all the swarms that are going way back and its eruptive history and all that stuff. So basically, people need to chill till they read this study because it just came out last year. So it basically says everything that it's doing. So I don't know why everybody's all like freaking out right now. I don't think they've read this study.
Yeah, there's a lot of people freaking out because there's been some movement, and it's not unheard of, but they're all flipping out all over the internet right now. Oh, it's gonna blow! They're telling people to leave. So
I can copy it here and put it in.
Yeah, you're looking for a copy of it. There's a gal that I like on YouTube here, and she's talking about it. And thank you, Canuck.
Because it just came out at the end of last year, and it explains like all the times it swarmed previously and what it was doing. It has all the maps of where it is and everything. It's like super detailed. And it talks about like when it did it in 84 and 58, all these different things. And it talks about like when it last erupted, which was 1538, but it wasn't like a caldera eruption. It was just like a little blowout. And it explains the cycles of it and everything else. So people need to chill till they. Which I don't know why, like the authorities there don't just say all this stuff. Like there's studies, they can just go read it. So I don't know why people are like going like
because they don't know about this stuff, and that's kind of what we do here. Is we try to bring more information because it's not there.
Like it takes a while to read through it all, but you understand what it's doing. It's not like the first time it's had quake swarms and everybody like all getting freaked out. But I don't know.
Right.
Like it's happened before because it's been doing it for a long time. So it's just now we're even more aware of it, right? Because we have all the equipment to try and monitor it and everything else. But I guess the meters and the GPS things they've been using over there, people have been stealing them. so they're having all sorts of problems even getting the right measurements, by what I read.
They're having trouble getting the measurements because somebody stole the stuff?
Yeah, people are stealing the equipment. So it's not like what it is in Iceland where there's only a few people around there, right? Well, there's like whatever the population of Naples is, whatever it is. I forget what it said, 3 million people or something all that. But there's all sorts of these people that are right on top of where they're trying to monitor everything, right? So it's totally different from Iceland. Like a few thousand people compared to 3 million. So they're having like a hard time even monitoring everything properly. Because they put instruments out there in order to do all the stuff, like GPS measurements, like the same things that they're doing in Iceland, right? Trying to figure out how much the ground is rising up and all that. And they go out and the instruments are all pieces are missing or whatever. So I was reading
I
all this
know
stuff here the other
in
day.
Iceland, they're worried about a pyroclastic explosion too. When the magma reaches the ocean, they're a bit worried about that.
Yeah.
So
But
it's
see, the problem with Campo Agri is that most of it's underwater. So if it decides to do its little rupture wherever,
right,
if it's underwater, it's going to be trouble. Like
right.
it wouldn't be as much trouble on land, but if it does it in the water, because it shows all the maps in there, like it shows like where it had its rupture before in 1538 was the last time it had it. So it
Well,
shows, and all
there's
the
so
maps
many,
are in there where it is.
right. There's so many people living in Campi Flegrei in the belly of this volcano.
Yeah.
And
But
they're
of
all
course,
wiped out, dude.
yeah.
I mean, it's like what is it? What's the big volcano right there?
Vesuvius.
Vesuvius is Vesuvius all over again. These people haven't learned the history of Vesuvius. It's still a live friggin' volcano, which is
Well,
connected.
I don't understand that because they live right there. You'd think they'd know about their stuff.
I know.
They're living on. Doesn't make any sense to me.
Oh, it ain't gonna blow up. We're gonna go by the ocean. We're gonna live by the sea.
And of all the stuff I've read on it, there's no way they can evacuate people out of there because the roads are all no good and they're too congested. And somebody said, "Oh, well, they're going to have to come in with ships and take everybody out of the harbor." Well, how's that going to work if it's erupting in the harbor? This is what all these different people are saying. So, and then they're saying, "Oh, well, we can get everybody to come from the naval base there and rescue everybody." But it's like they think that it's like they're just going to be able to come in there, and they said, "Oh, we got to dredge the harbor because we need to get the big ships in here to evacuate them." So it's just like one thing after another now because it's turned into this thing because they're trying to figure out all these different ways to get all those people out of there. Which it's like in 1538, the last time it had an issue where it had a little mini rupture or eruption. It wasn't, like, of course, a caldera eruption. It was just like a little blowout.
Right.
But way less people there in 1538, so it wasn't that big of a deal. Wasn't 3 million people all sitting there right on top of it like what there is now. That's the difference. So I don't know. It's just I don't know what they're going to do if it did erupt. What would they do? They can't do anything. They said that's all the authorities there now, and all the people are getting all mad at them, the authorities. But like, what are they going to do? I don't know how they're going to get them out of there. You need like 10 million helicopters to come in and pick everybody up.
It ain't gonna happen. It's like 4 million people that live in the area.
Yeah,
it's just like it ain't gonna happen.
It's like whatever. So I don't know. It's crazy. And everybody's saying, "Well, we got to figure out some way to how are we going to get everybody evacuated?" Well, I don't know. It's not going to work. It's impossible unless everybody just moves. But this is what they were saying. Well, then they said, "Well, you got to find 3 million place for like 3 or 4 million people to move to." So I don't know. It's a big cluster, but it's just like everything else.
Well, it you know, as always, it's we can go on for hours talking about different subjects, and we don't want to burn ourselves out. I had a big job today, and I'm purely exhausted. But it was been a good evening to spend with you, brother, and I so enjoy it. Thank you, and I want to thank everybody else who's listened and who will listen. Hopefully, we can those people who would listen and who would watch what we've put out here and listen and can comment. And we encourage that. If you want to be on a rabbit hole, hey, shoot me a line at jsldiscussions@gmail.com. and we'll try to do that. And or you can reach me at joeslicklive@gmail. Or you can come to twitch.tv/joeslicklive, and that's where we're live, 24/7, as well as on locals, and the replays get put on YouTube and Facebook. Right now, Facebook is live as well as locals, and so is YouTube, by the way, and Twitch. And primarily, we're on Twitch 24/7. So if you want to join in and you want to have a discussion, there's many people here. It isn't just me. It isn't just Canuck talking. Talking out our ass. Most of the time we do talk out our ass, but we're having fun. And we're open to you having a time to come out and discuss some geological thought. You might disagree or might agree with us and might be able to add more to it. We do a lot of teaching here, a lot of examination of teachings, and we have a lot of fun doing it. Canuck, is there anything you want to close out on what you want to say for the evening?
No, can't think anything else because I got to go back to doing my World War III research. Now the baseball game was earlier today, so I don't got to worry about that tonight.
And so why is two guys plugged 19 times this year alone? One guy hit 9 times, the other guy hit 10 times. What the hell is it? People were they from from Houston? Those two players, because they got big target marks on them. They're getting plugged. One guy got plugged 4 times in one night.
Yeah, well, one guy's how he hits because he
crowds the
plate and how he swings. He leans in and leads with his hands, so he usually gets hit in his
I watched him get hit in the knee or the calf, and I was like, damn, that would God.
And he's he doesn't I don't think I've ever seen him move try to move away from an inside pitch. He's always going right into it.
That's a free get on base, right?
Yeah, so that's how. But he keeps breaking his wrists and stuff. But now they have him wearing all this stuff on his wrist, but he still gets hit, so it's not going to matter. And then because he was a catcher, he breaks his hands, getting hit with foul tips and stuff too. So
my team, the Angels, they just lost their catcher today.
Yeah,
or
so
last
it's
night.
crazy stuff. Yeah. But the way it is in baseball now, there's 4 good teams in each league, and then everybody else is terrible. That's how it's working.
Well, we did a little baseball. That might get some people a little wiggy. But hey, love you, Canuck. Love you all for listening and being here. Again, if you want to come over to twitch.tv/JoeSlickLive, join the live discussion all the time. It's always here. It isn't just me or Canuck. It's everybody. And there are plenty of people here that are knowledgeable or have an opinion one way or another. And it's a good group of people, and they're pretty special. No, they don't get on the short bus, but we have a pretty fun time. Yeah. But big hugs, y'all, and remember, don't get none on you. Thank you, Canuck. Love you, brother.
Alrighty.
Good night.
Good night.